So I'm Benjamin Lewis with the CSU Chico Center for Regenerative Agriculture and Resilient Systems, and we're partnering with the Pekin County Farm Bureau to talk a little bit today about soil sampling, specifically around what healthy soil is and how we can measure that with soil testing and also with qualitative and quantitative testing. So qualitative is when you sort of describe it in words and observe it, and quantitative would be if you describe it using numbers. So, a lot of questions here for growers. Has anyone here taken a soil sample before? Dana has. No?
No, I leave that to Zion.
Okay. Zion, you've taken it before. Dana, in your experience, do you work with growers that kind of do it on a regular basis or an annual basis?
Yeah, well, we just sent out all of our 2022 projects, the post, because we collect 1 year post soil organic matter. We're not doing that for the new ones though, because it's a real pain.
Because they're done with the grant.
Because they're done, so we can't reimburse. So I would say right now it's probably 50-50 of like who continues to take them and who just says, no, this was really only the grant and I don't for whatever reason. So.
Have you done any soil sampling around or testing around like NPK, cation exchange complex?
Not specifically, because that's just not what we are tracking.
That's not what you're looking for. Right.
That's going to be changing, and we're coming up with different protocols for soil sampling. Because I think the problem that we were running into is we track the organic matter, but we can't tell if folks get help from THCs, then we can trust the data maybe a little more. But we aren't super confident that farmers are taking them correctly, taking them in the same spots, labeling them correctly, doing it before your practice so you're not getting like compost and stuff in your sample. So we've just had this skew of data that I don't know how reliable it is that they want to make maps out of, but again, like the consistency of it is a little hard to judge. So.
Great, yeah, I think we plan on sort of covering all those things today about how to take a good soil sample. So it's not just grabbing soil and tossing it in a bag, but having a little bit of methodology behind it. But first I just want to talk a little bit about what healthy soil is and sort of what it would look like and sort of what are some properties of healthy soil. So anyone think of some properties of healthy soil? What does healthy soil look like?
Agri stability.
Should have said you can't.
Oh, I'm sorry.
So later. Yeah. So that's part of it. Before we'll explain what that means in a little bit more detail. But what do you think happens when it rains on a healthy soil? Where does that water go? That's right. It infiltrates into the soil where it becomes available to crops rather than running off or ponding on the surface of the soil. What else is a property of healthy soil around water? How water behaves in healthy soil? When it infiltrates, does it just go straight through and out the bottom?
Doesn't it spread out if it's in a heavy soil, so it like disperses farther?
That's right. So it can healthy soil generally has a higher water holding capacity than soil that is less healthy or has a lower soil organic matter. And so that means that soil holds on to more water, and holds on to water longer throughout the season, which lowers your irrigation requirements and just increases general plant health. What about roots? What do you think plant roots would look like in a healthy soil?
What else?
That's good, yes. Yeah, so basically just more root growth, more root volume, and also you expect to see more fibrous roots. And so those fibrous roots, those hair-like root structures are actually where interchange of bacteria, fungus, and ionic nutrients is taking place. So healthy soil has just better root growth, more spread out root growth, so you're increasing your capacity just to access nutrients within that soil. So these three things all kind of point to one thing that I think is sort of surprising. So a healthy soil, if we took that by volume and separated it, about 45% would be a mineral fraction. We'd like about 5% to be an organic fraction. Often California soils are much lower than that, so that's a good goal to shoot for, is that 5%. So 45 and 5, that is 50%. Where's the other half of the soil? What makes up the other 50% of the soil?
Nutrients?
That would be in the mineral fraction. This is by volume, and so it's counterintuitive. Like I said, it's actually space. It's nothing. 50% of a healthy soil is empty space. I should say empty because it's full of either oxygen or water. And so that's what you want, is you want a soil that has a lot of space, or what we call porosity, where water can infiltrate and actually get into there, and also where oxygen can exchange. Because a healthy soil is a living soil that is breathing and exchanging oxygen with the biological fraction of that soil. So there's two soil tests that are sort of common that we can measure sort of the amount of space or porosity in the soil. The first is what we call bulk density. So if you recall from your physics class, density is just the weight of something over the volume of something, right? So grams, pounds per gallon. So bulk density is if we just took a certain a soil clod and we knew what the volume is, and we took the water out, dried it down, and we weighed that. And so what we're looking for is a lighter soil. And that lighter soil, that lighter bulk density, means that there's more space in that soil, more porosity. So more space for air, for water, and for biology. So it's just sort of a measure of how much space does your soil hold. And so it's also important for future calculations. If you want to look at what the total organic carbon stocks is, you kind of need to know how much your soil weighs per unit of volume. So you can decide how much, acres a unit of volume, so we can figure out percentage-wise what's in there. The other soil test that measures this porosity is, as Zion mentioned, is called wet aggregate stability. So an aggregate is a group of soil particles that is held together, usually by some biological action. So roots, sort of biological glues that's produced by fungus or earthworms, or root exudates, is all kind of holds these little soil particles together. And when there's lots of soil particles together, there's lots of space in between them. Wet aggregate stability is the measure of how well those aggregates hold together when they get wet. If you have a nice amount of space, but then it rains and it gets wet and it all just falls apart and turns into dust, or mud, then you don't have very good aggregate stability, and you don't have good porosity. You don't have the ability to infiltrate water or to hold on to water. So that's a test that you can take a soil sample, send to the lab, and get a number on these. I should back up and say that any healthy soil program would start with a benchmark and then setting up a measuring and monitoring plan, just like you would any fertility plan, where you kind of figure out where you are, where you're starting with your soil, and then measure at periods that make sense for that test to see how far you've gone. And really what we're looking for is not a particular number or goal that you're trying to reach. You're just trying to improve throughout your seasons. What do we want from a healthy soil? What do we want the relationship with nutrients to be? You can answer this time, Zane.
Nutrient cycle, and that's it.
That's right. So you want a lot of availability of nutrients, and you want those nutrients to be cycling through the system rather than leaving the system. So if you had a lot of runoff, that would be one way that nutrients leave the system when they're attached to soil particles. Important nutrients like nitrogen, there's very soluble in water, and if it was just going straight through the system and out the bottom, then you're losing that through what's called leaching. Of course, that's also ending up in groundwater and surface water, which is then becomes a pollutant in our system. So you want that water, you want that soil to hold on to that, both through increased water holding capacity, but also through nutrient cycling. And so that means that there's a lot of biological activity. So this nutrient cycling and availability really depends in a healthy soil on two main things. First is the number one thing that we measure with the Healthy Soils program, which is what, Dana?
Organic matter.
That's right. Soil organic matter. So that means the amount of organic matter that's in your soil. And like I said, we want that to be, upwards of 5%. Soil organic matter is the engine that the biological fraction works on. It's what's driving nutrient availability in your soil. There's off-farm inputs of nutrients that you can use like fertilizers, but there's inherent fertility in your soil which is locked up in that organic matter. And it's in a form that isn't immediately available to plants, but it has to be digested through a biological system like bacteria. So soil organic matter is typically 58% carbon and 5% nitrogen, which doesn't sound like a lot, but considering the top 6 inches of your soil weighs somewhere around 2 million pounds, if you have 1% soil organic matter and 5% of that is nitrogen, it's about 1,000 pounds of nitrogen per acre in your soil. A crop like this probably takes, like an almond, less than 200 units. That's 1,000 pounds. Now obviously that's not available all at once. Like I said, that has to go through the biological system. So the first thing is to have organic matter in the soil, and the second is to have healthy biology that is cycling those nutrients through. So you need the soil organic matter to bring the biology, and then you need the biology to mineralize that soil organic matter. That's mineralization is the term for when nutrients are released through the biological digestion of the bacterial fraction. So there was this UC Davis study that shows that the soils in the Central Valley release or mineralize about 70 to 110 pounds of nitrogen a year, straight from the soil organic matter. And that 70-110 range was at 1.5% organic matter to 3% organic matter. And we know we've worked with growers who adopt regenerative practices who are pushing up in 4 to 5% organic matter. At 5% organic matter with a 3% mineralization, which is doable in California, that's 150 pounds of nitrogen per season that's available, or it's 150 pounds a year in a single acre, and about 75 pounds during the growing season or more. So I think a lot of growers right now, knowing what the cost of fertilizer would be happy to have an additional free 75 pounds of nitrogen available to their crop. The other quality of healthy soils is that it creates healthy plants, and that those healthy plants have a higher pest resistance, disease resistance, and just increased tolerance to stress. So good reasons. It's not something they can necessarily measure with a soil test, but a good reason to build healthy soil. And that, of course, is one of the main takeaways here, is that these soil properties that I'm talking about, water infiltration, water holding capacity, tilth or aggregate stability, nutrient availability and cycling, and healthy plants, these are all something that is driven by management. It's not just what you're given in your soil, it's how you manage that soil. So you can build healthy soil, and it can be built over time through management practices. You can also measure and monitor these metrics, and that program basically starts with a benchmarking current conditions, testing over time, and looking for specific improvements.
So I gave you guys 2 papers. One is the CDFA soil sampling protocol. This is what's used for HSP grantees to go through and do the process. And one of the first things when I'm with a grower talking about this is really just teaching them how to fill out the bag. A good soil sample starts with the bag. Fruit Growers Lab was nice enough to give us a ton of documentation, soil sampling, and tissue bags if you guys are interested in taking any. With healthy soils or any grants, I usually have the grower learn how to use the Compass app on their iPhone or Android, because it gives them the coordinates. And that's something I will write on the bag, as well as the chain of custody for the grower. So when they come back next year, they can go, where did I take that? And be like, oh, there's a point. Follow GPS.
Yeah, so that's the first sort of rule here, is that you want to take a soil sample at the same time each year and in the same location. Or
and
as close
before
as
your
it-
practice too.
Right.
Not before. You don't want to be taking it after you applied your compost and your organic matters jumping because you just did that.
And
Not after a rainstorm.
Not after rain, yeah.
Yeah, before any inputs, treatments, or tillage
Mhm.
events, because we are looking, and especially if you're looking at any biological activity, you want there to be sort of average soil moisture or some adequate soil moisture. You don't want it to be totally dry or saturated, and generally also temperatures above 50 degrees, which is just a good. It's a lot easier to take soil samples if it's warmer than 50 degrees. So.
But yeah, so going over kind of like with the compass, it has the coordinates. I'll have them either screenshot it as well, just so they have it for the record, writing on the chain of custody, writing it on the bag, just so we have lots, as well as field name. Some growers have great names for their fields, some are just like field 1, north side, things like that. And that helps when this gets sent off the lab and they look at the chain of custody and they're like, okay, this bag correlates with that sample. So when they send back their document with those results, you're able to correlate the two. Once we get all that set up, again, the next thing we're going to need, we have to have a bucket, pen. You need either a sharpshooter or a core extractor. We'll be doing a composite sample, so we'll be doing 9 locations. Typically, I have growers pick the locations that are most standard for their field. I don't want the worst. I don't want the best. I want something that's a good average for all of theirs. Yeah, you don't want to just go like, oh, all my trees are dying on the northwest corner. I'm gonna go do all my sampling over there. That's not a really good representation of your field. You might do additional sampling for your personal use, or if you want to see, am I lacking nitrogen? What is the issue that's causing this die-off? Or my trees or wretch not to be producing as well. Some things like that.
The typical one strategy that I've seen growers use, not for healthy soils, but for just in general, is most growers know their best field and their worst field. And so picking your best field, soil samples are kind of most useful when it's to be able to compare it to something. So if you look at your best field and your worst field, wouldn't you want to know the difference between there? Like what's going on in the soil? And then if you want a third option, one that you find most representative of sort of the average field, and that's sort of a good, those would be 3 different samples that you'd send in so you could compare and contrast.
When we're actually going out to take the sample, so again, it's a composite, we'll be taking 9 samples in each location. The first step is really just going to clear that surface. I don't want any of this organic matter that's on top, so last year's crop or any weeds to really come into that sample. So we're kind of clearing about a 6-inch area around, and then we're going down 8 inches and making a 2-inch hole as well. You'll definitely see with some compaction in the orchards, it's a little hard to get pretty deep down in here. And this is something when you get a chance to on the table, I took aggregates from this field as well as from the vineyard. Kind of looking at the difference of conventionally grown versus more of a permaculture, more regenerative in some aspect of living cover on the ground. And you can see that aggregate stability difference as well as the soil structure. With this, you see a little bit more massive soil structure versus the vineyard, which is more of a granular. So once you get about 8 inches, which is about the shovel, you're going to go on the side here. You take about a 2-inch slab out. Now you're going to kind of bring it up. Pretty standard, making sure there's no any roots or real large rocks in here. I'm going to drop it in our bucket once we have that slab. And again, we would go do this 9 more times around, filling in your hole, especially if it's not your orchard.
So something to note is that is what we call a subsample. So when we talk about soil sampling and sending in a soil sample, almost all soil sampling is going to be a composite sampling, right? You don't, if you want to see how this orchard is, you don't look at one leaf, right? You want to look across the orchard. So you would you would take subsamples from different areas and then you aggregate them together into one bucket, mix that all together, and then draw from that, and that becomes your aggregate sample or your composite sample.
And I'm not going to make you guys watch me take all 9, but we'll get one more just to kind of see how the mix process.
Because this is not full
do an
ocean.
RCPP, so Regional Conservation Partnership Program, and a part of that is we do a SEMA 216. So that is a soil sampling where a technical system provider will go out, take the soil samples for the growers. Typically, we're taking a sample on every field that has a different soil system or soil type, production system, or if there's any large elevation or changes that the grower wants to kind of measure. We'll go out and take samples for them, and then we do a write-up, which is anywhere between 50 to 25 pages, kind of talking about what we're seeing. We'll do that prior to the application, and then we'll do a post, so we'll do it after the grower does the conservation practices. And that's a really cool way to kind of see those differences as well as have the interpretation for the grower.
SEMA 216 is a suite of tests that look again at soil health rather than just like cation change complex. And so some of them are the tests that I mentioned today, and then there's some other more technical ones that I'm happy to go into if you're interested. But you can look at basically the amount of nitrogen, potentially mineralizable nitrogen. You can look at mineralizable carbon. You can look at the relative right epoxy, which is looks more at soil organic carbon takes a long time to change if you're looking at just a percentage, right? If you imagine when I say 1% of 2 million pounds is a lot. So you got to add a lot of organic matter before you actually see like a percentage change. Whereas epoxy is looking more at what is what's called a labile carbon fraction, which is this, it moves quicker and it's cycled quicker. And so often we see changes in management, we'll see changes in the carbon from epoxy versus soil organic matter. It means permanganate oxidable carbon, which is just the way that they, it's a chemical acid that they use to extract carbon.
Yeah, so the next part, once we have our bucket, we have all the composite filled in, what I like to do is just kind of pick around, make sure I'm not having, again, any heavy roots, any rocks in that sample. You can throw your test off. Roots organic matter. So if you got a lot of roots in there and they're large, you might throw off the organic matter percentage. Once we have this, I'll also fill out the chain of custody while I'm doing it, just so I'm making sure that that sample number and field ID is correlated with what's in the bag. I know growers sometimes like to do it when they get back to the truck and they can mix them up. I like to do it as I'm putting it in. So you'll see this is a chain of custody that comes from Fruit Growers Labs, which is our local lab out here. You put all your client information, you put your soil sampling information of the soil sample number, the location, so you can put that coordinates, you put the field, where it's located, the crop type, the growth stage, and the sample depth. And then on the sampling info, you'd select what samples you're doing or what tests you're running. So on this one, we're running organic matter, so I'll just put a check mark there. So the lab knows on this sample, run organic matter.
How far, when you're doing a soil sample, since you have to get 9 of them, how far are you typically like spacing them out in a field?
It depends. There's a lot of depends on that one. Again, I've had growers where they have one sample that they're submitting for 200 acres. I'll ask to maybe spread that out more than a grower that has a 5 acre where, yeah, if you're in 100 feet of each other as you go through. There are different soil sampling procedures as well. I'm blanking on the name, but I know there's like a step stool where you're basically having a straight line.
Yeah. So you can look at, it really depends on what you're asking and what you're looking at. So if you have a field that is, any sort of differences in management, if you manage one field different than another, or it has a different location, and obviously you would take separate samples in that. You generally want to get the whole field unless you're trying to diagnose a problem, and then maybe you're looking at a certain area. So one way, if you're trying to get a whole field, you can either just do what's called a transect, right? I like to start at one corner and end up at the other corner, and try and take subsamples along the way, relatively at random, but spread out. I usually do 10 across a field and get more than this on the end. So you're trying to get that whole field effect there. If you know that you have different soil types, and if you're looking at the Sergo data online, mapping out your field, you can do what's called a stratified soil sample. So if you're trying to say you have 3 different soil types, one is 30%, one is 50%, and the other 20%, then you would take 2 from the 20%, subsamples from the 20%, 3 from the 30%, and 5 from the 50%, and then you would have something that's representative of the diverse soil types in your field, numerically representative.
Don't throw it in your cab and leave it on a hot day. You'll bake off all your organic matter, your microbes in there. If you need to ship it, putting it in an insulated bag and putting an ice pack on it and shipping it that way is important. Making sure you don't put the chain of custody inside the bag with the soil. Put it outside in the box. That was something Fruit Growers Lab and Ben really highlighted, and making sure that you're not sending it in where they're looking for that. Also, make sure you're sending enough soil. If you send up half of this bag, it might not be enough for the sampling that you require. These do come from Fruit Growers Lab. They say it's about the perfect size for running in the samples that are required. If you do have questions or you're doing a lot of samples, it might be worthwhile calling them up and saying, hey, I'm running these samples. How much soil should I send them for?
Generally, the more tests you're doing, so this is soil organic matter is one test. If you're doing multiple tests, you need more soil because they basically take it out and process each of those separately for each of those tests. So yeah, and they can give you guidelines on that with the soil lab. I also like a Ziploc bag is fine, and you can write on it with the Sharpie. That's where you see more people more likely to put their paper in with their soil, and there's condensation, and then it gets there, and the ink is all stained and run, and like labs hate that.
Especially if you're sending to a lab that's maybe not local, like you're sending to a ward laboratory, a lot farther, making sure it is an iced and insulated bag. It's going to be really important because it might be in transit for 5 or 6 days, depending on when it's sent.
Another thing we found is that it's depending on what test you're doing and how far you're sending it. You don't want to send it at the end of the week because if they're not there, it'll sit wherever for 2, 3, 4 days. So we try to send them like Monday or Tuesday.
Age, what are the parameters? Where should I be falling in? Is it too acidic? Is it too saline? That's where you're going to be looking at that information. They also give you an example of a testing result on a field. So again, you can see the farmer's name, ABC Farms, their address, the sample, the lab ID, when it was sampled on, who was sampled by, when it was received. And those are all important, especially when it's sampled date as well as received, depending on your grant. Making sure, again, you're not sampling after an application. Compost, cover crops, doing anything like that.
Get a sample and they don't know who it's from and it's improperly labeled, like they just toss it. They don't even, like how do they can't even reach out and be like, oh hey, you sent this, but it's not gonna work. You just don't do anything with it, and then you never know. You have to do it all over again.
Especially if you've done it prior to your application and then it comes back after your application that, hey, there was an issue with your soil sample.
Right.
I think we've had a couple like that's happened too.
When I was an inspector, I would do sort of investigative soil sampling and pesticide residue sampling as well. And that chain of custody form became very important because then it became a legal document to show that that soil sample or residue sample never left my custody, wasn't tampered with or contaminated in any way until it was sealed and in the mail, and then it was not open until it got to the lab. So that generally not as important with HSP, soil organic matter sampling. But in some cases it does become a legal document because if something is shown up on there, that it then has to become adjudicated. Then that form becomes an important piece.
So on the packet, that first one we do have from Fruit Growers Lab that is looking at nutrients. This is an almond soil analysis. So that first one we have the primary nutrients. Again, we're looking at nitrogen and nitrate, phosphorus, potassium, NPK. We're looking at secondary nutrients, things like calcium, magnesium. Fruit Growers Lab does a really nice job with their graphs too to make it really easy to read. They have this very low, moderate, optimum, moderately high. It gives the growers a good idea of where their nutrient levels are at. So you can see on nitrogen or nitrate, it's very low for an almond variety. Again, these are going to be particular for the crops, which is what that nitrogen uptake should be.
Bulk density. This is one way as you sort of indirectly measure that. This is called a penetrometer, and it's missing its tip. Oh, there it is. Which basically it's sort of spring loaded, and you can use it to measure the amount of force that it takes to penetrate the soil. Each demarcation is 3 inches, and you can see the green is for there would be no obstruction to root growth. It's optimal for root growth. Yellow is it may start to limit root growth, and red is it would severely limit root growth. And so I like taking this. I have one in my truck as well, and I like taking this to growers and just handing it to them, and then like I won't see them for 20 minutes. And I'm just poking things in their field because it's really fun to poke soil if you're into it. And so we sort of push down, and you can read what it says here. And then if you don't want an upgrade from the shovel, if you're doing a bunch of these, this is just a soil core where you can just kind of step down to take a soil sample. You can spend a lot or a little on these things. Generally you want to take like a butter knife with you so that you can get it out into the bucket. It's just a lot quicker to take a lot of soil samples. I recommend making a mark at your, I think that's my 6-inch line there. Either the 6-inch or 8-inch or multiple. Some of them come pre-marked as well, so that you can be consistent with that. And if you're interested in what aggregate stability looks like, it's a pretty good example.
Roll left.
Did I hear left?
I said left, you said right.
Yeah.
We were talking about this all day at work now, so we need to know.
We'll tell you next time. Tune in next time to find out who's right. Yeah, so this one, there's much less sediment that's fallen to the bottom, and you can see it has a bit more of a structure up here. You see here all of this sediment at the bottom, and one way to kind of check this out, see how much falls down there. It's a lot more cloudy. And it's also, you see here, it's a little sort of slumpy in there. And if you have more of a trained eye, when you look at this,
So that's the vineyard, the more.
this has more of a crumb structure to it, more of, which is like a nice, that's what we're looking for. You can see there's little roots in there, and you can also see some holes like from bugs. This is more, yeah, sort of blocky, massive structure, or platy structure, I guess. Massive means it doesn't really have much structure at all. Platy means it has this little bit of a.
That's the one on the left.
Yes, that's
You
this.
guys aren't able to run machinery through it either.
So, yeah, this is a less structured soil, and this is a
We're just gonna put it
a
out
more
there that
finely
the
structured
farm,
soil.
has the better soil.
So, tillage can really affect this.
They're not running machinery.
Yeah,
through
tillage.
it.
Run machinery.
And machinery, yeah, compaction. So typically in almond harvest, machine harvested, you're running a lot of heavy equipment through here several times a year. So compost that add bulk and tilt to the soil, because organic matter resists compaction. More than the crew of Enterprise ever needed to know about soil.